Today, let's talk about natural deduction. We will introduce conditional proof and indirect proof in this video. The method of deriving the conclusion of a deductive argument using rules of inference successively to prove validity of the argument is as reliable as the truth table method if the rules are used with meticulous care. However, it improves on the truth table method in two ways. It is vastly more efficient, as has just been shown, and it enables us to follow the flow of the reasoning process from the premises to the conclusion, and is therefore much more intuitive and more illuminating. The method is often called natural deduction. Using natural deduction, we can provide a formal proof of the validity of any argument that is valid. First, let us prove modus tollens using natural deduction. We have two premises, namely P implies Q and not Q. And our conclusion is not P. So let's see how we prove it. We know that if P then Q is true, it's equivalent to saying that not P or Q is true. And that is material implication, abbreviated as IMPL. And then using disjunctive syllogism, in the third line and the second line, we have not P. We can notice that in the statement not P or Q, we can eliminate the statement Q because we know that Q is false. So that's how we prove the modus tollens. Now let's prove hypothetical syllogism, abbreviated as HS. We have two premises, if P then Q and if Q then R. And our conclusion is if P then R. So in order to prove HS, we have to apply the assumption for conditional proof, abbreviated as ACP. In the third line, we assume P is true, and we have to draw a vertical line. We assume that P is true, and that's ACP. In the fourth line, we have to write Q using modus ponens. In the first line, we have P implies Q, and the third line, we have P, so we know that Q is true by modus ponens, abbreviated as MP. Using the same logic, we know that R is true because Q implies R and Q is true, also by modus ponens. Finally, we have P implies R. And in line 3 to line 5, we have used conditional proof. So we use the abbreviation of conditional proof as CP. Line 3 to line 5, we have CP. Now let's introduce another kind of proof, which is indirect proof, which is same as proof by contradiction. To use indirect proof, we have to assume that what we want to prove is false, and then we derive a contradiction. And finally, we know that the original statement that we want to prove is true. For example, we have this statement: not M implies N is true and T is true. And then in second line, we write if N is true, then P is true. And the third line, we write if T is true, then not P is true. And our conclusion is M is true. So to prove that M is true, first we assume that not M is true. We apply the assumption for indirect proof, abbreviated as AIP. Okay, now since not M is true, by modus ponens in line 1, we know that N and T, both of them are true. By line 1 and line 4 modus ponens. As N and T are both of them are true, we know that in particular N is true by simplification, abbreviated as SIMP. Also, we know that P is true. Because we know that N is true, and if N is true, then P is true. Then using line 2 and line 6, NP. Also, we know that T is true because in line 5, we have N and T is true. That is simplification. Since T is true, we know that not P is true by modus ponens, line 3 and line 8. So we know that P and not P are true, both of them are true at the same time. 9799 conjunction. That is obviously a contradiction because P cannot be true and false at the same time. So we have arrived at a conclusion that not M is false. That means M is true. From line 4 to line 10, we have used indirect proof, so we write 4 to 10 IP, where IP is an abbreviation for indirect proof. Now, let's prove the constructive dilemma, abbreviated as CD. We know that if P then Q is true, and we know that if R is true, then S is true. We know that P or R is true. Then we have a conclusion that Q is true or S is true. Let's prove constructive dilemma by a usual method in natural deduction, which does not rely on indirect proof. Let's look at line 3. We can transform the P or R into not P or R, where we have used double negation, abbreviated as DN. So we have not P implies R by material implication. And let's look at line 1. P implies Q is equivalent to not Q implies not P. And that's transposition, abbreviated as TRANS. And using hypothetical syllogism, and we look at line 5 and line 6, we know that not Q implies R, because not Q implies not P in line 6, and not P implies R in line 5. And we know that in line 2 we have R implies S, and we know that in line 7 we have not Q implies R. So we know that not Q implies S. Line 7, line 2, HS. We use double negation again. We use double negation again when we have this statement, not Q or S. And we have used material implication again. So finally we have Q or S. That is double negation. So we have shown that the constructive dilemma is true by natural deduction. Now let's prove conditional dilemma using indirect proof. Proof of conditional dilemma using indirect proof. And we write the same assumption here. We first assume that the statement Q or S is false. And that is assumption for indirect proof. Then by De Morgan's law, DM, we have this statement, not Q and not S. In particular, not Q is true by simplification. As not Q is true, we have not P is true. We can look at line 1 and line 6. In line 6, we have not Q is true, and we have line 1 that P implies Q, so we know that not P is true by modus tollens. We know that not S is true because in line 5 we know that not Q and not S is true. Both of them are true. By simplification. In line 8 and line 2, we know that as not S is true and R implies S, we know that not R is true. By modus tollens. Notice that in line 3 we have P is true or R is true. In line 7 we have not P is true. So by disjunctive syllogism we know that R is true. So by line 10 and line 9 we know that R and not R, both of them are true at the same time, which is obviously a contradiction. So we know that the statement Q or S is true by the indirect proof steps we have shown in line 4 to line 11. IP. This is the end of my video. If you find my video interesting, please consider subscribing my channel, liking my video, and commenting down below. Thank you. See you in the next video.